general, the thrust is given by force due to thrust is the relative velocity times rate of change of mass. Okay, so in part A, thrust due to fuel will just be the velocity of the fuel times rate of change of fuel mass. And so velocity of fuel is negative 550 meters per second because it's traveling in the opposite direction of travel. The exhaust is traveling in the opposite direction to the rocket's motion, and mass loss is negative 4.2 kilograms per second because mass is being lost. That's the change of mass. And so this is just 2310 newtons. In part B, F of air, that's a bit trickier. It's, again, relative velocity times rate of change of mass. But here there are two components. One is due to the air itself, so that's velocity of the spacecraft in air times rate of change of rate at which air mass is added by the air. Right. And the other is velocity of the fuel times the rate at which mass is lost from the air. And fuel over dt, or this will still be dm air over dt because we're concerned with thrust due to air. And so we get F air is equal to V air is negative, the air is traveling negative 270 meters per second opposite the direction of motion of the vehicle times 120 kilograms per second. Plus, added to that is negative 550 meters per second as before, times negative 120 kilograms per second this time, because this is the mass loss term. And so what you end up with is 3.4 times 10 to the 4 newtons. Okay? And finally, in part C, we want power. And so power is given by force, the combined forces, thrust from fuel plus thrust from air, times distance over time. So that would be velocity of the aircraft. And so this is 2310 plus 34,000 newtons times 270 meters per second. And so power is 9.696 times 10 to the 6 watts. Note that we need an answer in terms of horsepower. And so horsepower is 1 horsepower is 746 watts. So we multiply 1 over 746 here. And what we get is 1.3 times 10 to the 4 horsepower.